Begin recording class. So everybody, can you put on your beautiful faces so we could see everybody? Welcome to Marianopolis today. Hello, hello, come on in everybody. Oh, I'm so happy to see everybody. Keep coming. We need a few more faces, few more people. Hooray, hooray. All right, everybody's here. All right, so here's the story, everybody. So today's class, we actually have a presentation. And I was going to make an announcement at the start of class that if you haven't registered for a date for your presentation, make sure that you go and register for a date, because a lot of people, well, not a lot, but a few people haven't chosen the date for their presentation yet. So make sure you do that if you haven't done it yet. So our very first presentation is now, and I'm going to hand over the hosting seat to Belinda, who's going to take over and tell you some very special instructions that you need to follow for this presentation. I'm pretty excited about this. This is like the first online presentation that I'm doing here. So let me just get a sheet of paper so I could take notes. And, oh, so something else about these presentations. Very important to note about these presentations is that they do appear on exams. So because they do appear on exams, you should take notes on them. The main things to remember, because I try to make the questions related to presentations be so that you can choose from among some of them to answer the question. So try to remember approximately the name of the study or the title of the presentation or what have you. What are its main points and what does it reveal about the self? That's what you have to make notes on. Okay, so, all right, I'm gonna get this going.
Yeah, so it's not hard. Everyone, please just answer C at every question. There's going to be 3 questions, and no matter what you think the right answer is, please just answer C. That's it.
Everybody got that? All right. Thumbs up, you got it? Everyone's gonna answer C? All right, you're in charge.
Okay, I'm so not sure what I need to do. Do you guys see anything on the screen right now? Okay, how about now? Can someone just open their mic and say yes, because I cannot see anyone.
I don't see anything.
Okay.
I don't see anything.
Because I'm on my iPad and I'm not really sure how screen sharing works on an iPad, but
okay, so here's something you can do. If you hit screen share and you hit iPhone, iPad via AirPlay, you might be able to share a screen that way.
okay.
Did that work?
Oh, yeah, kind of.
Oh,
there.
I see something for sure.
Okay.
I see line.
Yes, that's good. Okay, it looks like, okay. Well, there's not going to be any animation, sadly, but anyways, so today I'm going to be presenting on a certain study, but before we start the presentation, can everyone just try to answer this question? So there's a line on the left side and there's 3 lines on the right side. So can anyone tell me which line is the one on the left one? Like which line corresponds? Yeah. So Sydney and Ronton said C. You're all saying C. Good. Is there anyone who disagrees with this? I hope not. Okay, good. Next question. Same principle. So we have 3 lines once again and another line on the left side. Can anyone tell me which line this corresponds to? Is there anyone who is in disagreement with the answer C? All right. Anyhow, and we have the third, same deal. So which line does this correspond to? Okay, so clearly not everyone got the message at the beginning of class. I'm actually trying to replicate the study that Mr. Solomon E. Asch did once upon a time on opinions and social pressure. So I'll explain this study a little more concretely later on, but basically it was a study to try to test how much social pressure or how much conformity, like a majority who is against you, can influence your own opinions. So without further ado, we can go into it. So this image represents it pretty well, according to my opinion. So can the majority be manipulated according to your will? Like, could you go against the majority, or is it the opposite? Is it the majority that will usurp, well, your own opinions, is what the researcher was trying to find. So the first questions in history that were kind of related to this were brought up by a French philosopher named Charcot that we also saw in psychology class. And he studied hypnosis and patients with hysteria. So, of course, he only studied on patients, quote, patients who had hysteria, and only females at that. But throughout time, there have been other psychologists and researchers who also researched on hypnosis, but with like the general population. And what they found was that hypnosis works a lot like social phenomena, which basically you can tie the fact that when you're hypnotized, you're listening to someone and following their instructions unconsciously. But in society, this also happens because of social pressure. You're not even really thinking about it, but you just go with the general trend. So some early researchers that were researching social pressure and opinion found out some interesting things, that like how if you tie a text with an author, like Hamlet, like a passage in Hamlet with the author's Shakespeare, then people would be more adept to think that, oh, it's an amazing literary work, as opposed to if you take a piece of text from Hamlet and not say that it's from Hamlet and by Shakespeare, and people who don't know that it's from Shakespeare might think that it's a little less worthy or a little less grandiose. In the same way, some researchers also try to modify people's opinion on physical appearance and what they found attractive through social pressure or just authorities saying, oh, this is what is pretty. So the researcher who did this experiment that I'm going to talk about didn't really, well, he had some doubts about like changing people's opinion. So he did a much more controlled experiment that really had nothing to do with anything. But basically he took 7 to 8 guys in college or university and made them do a test of visual judgment like I did to you guys at the beginning of class. So he showed them 3 lines and a line that they have to pair it with. And all of the guys in the group knew that they had to follow a certain answer. So they would know, okay, for question A, I have to answer A. For question 2, I have to answer B, and blah, blah, blah. And there was only one person in the group who actually had to decide for what he thought was right. So of course, sometimes the group would choose the wrong answer anonymously. And the question here was, would the person being tested choose between the evidence of his senses or the anonymous opinions of his peers? The results of this study was that oh, and by the way, 123 people were in the position of being tested. So that's quite a lot for, for this experiment. So I think it is very generalizable. 1/4 of the people who are tested never agreed to the erroneous majority. So no matter what the majority said, how many people were saying that it was, that the right answer was, the wrong answer was right, they would never agree. So these people obviously have a more keen sense on individuality and what is right being what is right. But there are also 75% of the people who, to some degree, agreed with the wrong majority. So if, for example, the 8 other people in their group were saying that the correct answer was A when it was B, they would still say that the answer was A, even though clearly the answer was B. So the reason that they were agreeing to the majority was different. Some of them said that they were just simply wrong. They thought that their answer was wrong. Some other people were pretty funny and said that they didn't want to spoil the results. So they just went along with the unanimous decision. But more worrying are the group of people who thought that they had a general deficiency because they were seeing the right answer. So they thought that because the majority was choosing an answer that they thought wasn't the answer, they were the ones who had something wrong in like their natural person. And because they were wrong and they thought that they had a deficiency, they also felt the need to hide this deficiency by agreeing with the group instead. So the researcher decided to twist a little bit the different variables to find out if, well, like things like the size of the group or having someone who would agree with you would change the results. So they found out that in a group of 2 people where one person was wrong and one person was just giving out their answers, there was already a certain degree of like agreeing with the wrong answer. So when you do the experiment by yourself, they found that more than 99% of the time, the person had the right visual judgment on which stick was the right stick. But as soon as there's one other person who's doing the experiment with you and who says the wrong answer, you'll be more keen to agreeing with the wrong answer. And they increase the group to 3 people in total. So 1 person versus 2 people. And that increased the rate of wrong answers. And up to 3 people, it increased again. So I don't have the exact numbers, but for example, maybe when there's 1 person who's saying the wrong answer, you would say the wrong answer 10% of the time. But when there's 2 people who are saying the wrong answers versus you who is trying to say the right answer, you would instead say the wrong answer 20% of the time. But starting from 4 people and upwards, it doesn't really matter how many people are saying the wrong answer. Yeah, basically the size of the group doesn't matter. There was also the aspect of having a partner. So if you have a partner who's saying the right answers with you, then you will be more keen to continue saying the right answers. But if the partner decides to betray you halfway and join the unanimous majority, you will also pretty much immediately join the unanimous majority in most of the cases. However, if the partner just left the group randomly, not really agreeing to the majority, they're just not there anymore, then it didn't affect your answers as much. So we can see that the sense of betrayal or the sense of, oh, I'm following a person's answers is kind of a type of social influence as well. There was also the question of how wrong the group was. So for example, if the question was, well, 1 + 1 = how many? Is there a difference between the group saying that 1 + 1 = 3 versus 1 + 1 = 20? Well, what they found was that no matter how close to being right or far from being right the group was, the person who was answering would still say the wrong answer. So even if the right stick was 1 centimeter and the wrong stick was 10 centimeters, and it was very clear what the right answer was, the person who was being tested would still agree that the right answer was the very, very off answer. So the conclusion that we can take from this experiment is that, yes, social opinions and kind of peer pressure affects individuals very much in society. Only 25% of the subjects tested were pretty much unfazed by what the majority was saying. And even at that, they did tend to feel a little bit embarrassed while saying their answer, or a little bit uncomfortable saying their answer, because obviously all the other people are choosing another answer. So the researcher of this experiment showed that actually social pressure can influence people to a worrying degree, because, well, as we can see, some people would think that they tend to have a general deficiency if they do not agree with the majority. And even the subjects themselves who were tested, the 123 young men, they all agreed that individuality is more important than conformity in society, because if everyone decides to conform to each other when they're all wrong, well, we would have a lot of problems. So although the ideal, of course, is that self should contribute to the society through its own feeling and thinking instead of being dependent on the majority, what really happens in people's minds are different. And there's this need almost to conform with the people around us, even though you know that they're wrong. So yeah, that's the end.
Thank you. Yay. Thank you very much. Yay. All right. You can do clapping. Thank you. Oh, that's so cool. How do I do clapping? Wait, I'm sure there's a way to do it. Reactions. Oh, there we go. Clapping. Ah, yay. Well, welcome to your presentations, everybody. So that's a part of class. How do I get rid of the clapping now? How do I get rid of that? Wait, everybody seems to know how to do this but me. How do I end the clap? Can't figure it out. Oh, it went away on its own. Okay. I didn't have to do anything. So, okay. So welcome to your presentations, everyone, for this class. So it's coming for all of you. So if you are curious how that's going to go, you've seen a presentation. And I think it's worth noting that if you ever feel like you're in disagreement with a large group, your first thought should be is, am I a subject of an experiment going on where people are deliberately giving wrong answers to try and sway my thinking? So it's almost like that the physics principle from quantum physics. Like once you start watching the particle, it changes the particle. Like you can't not have an influence. It's like that kind of paradox. Like once you know that it could always be an experiment, it will always change your thinking that you are a experiment subject. Yes, opinions and social pressure, very famous experiment about the influence of group thinking on individuals. So thank you very much for that. So from here, we're going to progress to our I should have said, does anyone have any questions? Does anyone have any questions for Belinda? No, no hands, no one. Okay, so I'm going to move on then. So today's class, we're going to be watching David Eagleman's video because we need to watch it because it's really important for looking at a lot of different studies. And of course, ultimately, he's going to present his own view of what the brain is. I'm going to interrupt the video throughout class to kind of discuss it and talk about it because there's a lot of important stuff. And I think if you just watch it through, you don't get you might miss some important stuff as he talks about it. So I'm going to stop it periodically, which sort of forces you to watch it. You can rewatch it. It's available through the Marianopolis College Library, of course, to go and upload it or watch it at home, to stream it at home. I should put up instructions for that in case you're not sure how that works. So I'll say that much. I've also included some questions that I've put on Omnivox. And if you want to try and answer those questions as you watch the video, I think they hit on many. Normally before the midterm, I give like a list of questions to like study, and I just took the ones from a previous midterm that I've done about David Eagleman, and I've given you the questions that I like, the study questions for David Eagleman. So they're a little bit broad rather than specific, but the idea is you fill them in with specific details about the video, although we have an online exam, if I'm not mistaken. I mean, at campus exam, assuming they don't shut the school down. So you're not going to have the video in front of you to reference as you do the exam. So I won't be as picky about details as I am when you are at home doing an exam, let's say. So anyway, I feel like I'm getting ahead of myself here and babbling a little bit, but we're going to watch the video. I'm going to stop the video. I'm going to talk about what I think is important in the video, and then we're going to progress. The only negative to this is that I can't record the video. I can't save this for you. And if your technology fizzes out, you're going to have to watch the video on your own, because it won't allow me to, because of copyright reasons. So I have to stop recording, turn on the video, and then when I talk about the video, I'll try and remember to start recording again. So that may or may not be of any importance to you whatsoever. All right, so I'm gonna start the video. Before I start, just to recap, I believe we had looked at the Jensen family. Is that right? Did we get as far as the Jensen family? So why doesn't someone sum up for me what we learned from the Jensen family?
Well, they were all adopted after the age of 2, which is why some of them had one of them had severe ADHD, and then one of them had like ADHD but less severe, and then they're trying to cope with what happened during the first 2 years. Well, what didn't happen during the first years of their life with treatment now.
Okay, so the Jensen, their specific situation is that these 3 children were adopted after age 2. I guess they were 4 years old when they were adopted, and their first 4 years were in a state of horrible neglect as children. And the consequences of that neglect continue into their adult lifehood, where they have learning disabilities, they have attention deficit disorder. I don't know if you really picked this up. I mean, they might have said language problems. If you notice, their speech patterns were labored, and their vocabulary was quite limited as well. So they have learning language disorders. And I think there was also an implication of things like depression or anxiety or different psychological problems as well. So childhood neglect that happens in the first 5-year period of the brain's development has long-lasting effects, which was something that was observed by studying the long-term results of children who were in these states of neglect due to a war in Romania. So it's an unfortunate situation, but it revealed some things to us about brain development. So what did it tell us very specifically about brain development? Anyone can answer.
Okay.
Yeah.
Go ahead, Maya.
Yeah. So the brain development is very important at that age. And
Okay.
yeah.
Brain development is important at that age. So what happens in the brain in terms of development before age 5, let's say? What's going on?
So the brain forms a bunch of connections, and then depending on what's going to be useful for that person, depending on their environment, it'll lose those connections.
Mm-hmm.
And because they didn't have like a lot of experience, I guess, like in the world, their brain didn't like use any of the connections, maybe. So it kind of didn't form, it didn't keep as many as it should have.
Okay, so the brain from the ages of 0 to 2, the brain forms many, many connections, more neural connections than it will use in its lifetime, right? So I think it was something like, is it 2 million per second or so? 2 million connections are formed every second. I wrote that down, between the ages of 0 and 2. More connections than the brain needs. But from the ages of 2 to 5, those connections begin to be pruned back. Really important, good word, pruned. So like when you prune a tree, so I have plants around me, and every now and then, if they're getting a little bit long or messy, I have to cut out some of the plants so they grow healthily. The same thing in the brain, like from the ages of 2 to 5, connections that aren't being used or stimulated end up disappearing, which allows the ones that remain to get even stronger and become more efficient. So the Jensen children had lots of connections, but they weren't pruned back properly. And there are some long-term, like social, emotional consequences of that. So brain development from 0 to 5 is very important. It relies on the environment, which means if we're to think about how does self get formed, this partially looks at how the environment plays a role in shaping ourselves, that the environment we're exposed to and put into affects the way that our brains develop. And of course, this is assuming that the self is mediated entirely through the brain. So I'm making this big overarching assumption, this neuroscientific approach. Everything we are is through our brain. And of course, anything that affects the brain is going to have an impact on the self. And very specifically, this study shows that the environment we're exposed to affects the way the brain develops. And if brain development is affected, it will have an impact on the way we progress through life socially and emotionally. So I find it's a really good study that he kicks off with for this class, and kind of looking at the relationship between brain and self and the worldview that the brain shapes the self. And also the way that scientific studies get used to a degree to confirm our ideas about what is true and what is valid. Really like that. So we're going to continue with this video. And again, like I said, I'm going to pause it. We're going to end up having to watch part of it in the next class. That's just the way it is, but I think we'll all survive. So let's move on from the Jensen family and their situation. There was one other question I wanted to ask actually before I continued, and you may not have caught this, but one of the things David Eagleman says very early in the video is he mentions the way people used to think what constitutes the self. Did anyone catch what he said?
Like soul or spirit.
Soul or spirit, an immortal self. And that is a different viewpoint, right? If you think the self is a spirit or a soul, that's different from thinking the self is something that's created by your brain and the activity in your brain. So it's kind of just two different perspectives going on. Okay, so let me start this video. So I'm going to stop. First of all, I got to stop recording. I'm remembering to record now. So I like seeing faces when I talk to people. So you guys you could hear it okay in that one? Yeah, Zoom is very, it's a little bit of a learning process for me. There's a lot of steps to put, well, there's not a lot of steps, but putting up a video, I have to optimize for video. I have to remember all these things, and I'm old, man. I don't remember stuff. So anyway, we got to adolescence. So let's talk about adolescent and the adolescent brain. So at this point, oops, I just got distracted by some messages there. So at this point, looking at the adolescent, where's my notes here? The adolescent brain. Hold on, where did I put my notes? We're starting to talk about how now genetics plays a role in brain development and in creation of the self. So I'm pretty sure everyone in this room who's undergone puberty or is undergoing it right now knows that it happens at different times for different people, right? For some people, it happens at age 9. At some people, it happens at age 12 or 15 or 18 maybe, or even not at all if there's something maybe not aligned typically. So these are genetic determinations of when your body begins to undergo puberty and the result of the hormones, excuse me, that are released during puberty has an impact on, obviously, your brain development is one of the things that's affected. What part of the brain in particular did he say was affected by puberty?
The medial prefrontal cortex.
Excellent. The medial prefrontal cortex. So let me write that down for you. Medial prefrontal cortex. So this part of the brain, oh, I wrote that privately. Sorry about that. Medial prefrontal cortex is the part of the brain that is impacted by hormonal changes of puberty. Now, what is this part of the brain responsible for?
Like when you think of yourself, or how like you think of yourself in a specific situation, like with your emotions.
Yeah, so it deals with thinking about the self, especially in regards to emotions and social situations in particular. So that's when this part of the brain is being affected and developed, is during this particular time period. And the impact or the result of that is that social situations or situations where you have to think about yourself might be different from when this part of the brain has finished developing, say in an adult, for example. So in order to test this, again, they set up an experiment to explore this, how this part of the brain develops and what is the impact on that. So does somebody want to very quickly describe the experiment that David Eagleman and Ricky Subjani put together?
So he invited 3 people. 2 of them are teenagers and 1 of them is adult, and they put them on a machine that like measures their stress response. So do you want me to say the results, or just like they want people to, so they put them in a room that's like displaced to the outside world, and they want the other people from like walking past by to look at them and see how their brain is responding to the stress.
Okay, so they wanted to check the brain's response to a stressful situation for adults versus adolescents, particularly a stressful situation which involves people and thinking about yourself, right? Because people are staring at you and looking at you. So it's not like a stressful situation like, let's hold this person at a great height and threaten to drop them or something like that. Or it's not about necessarily giving them a really difficult test. It was a very socially stressful or awkward situation, let's say. So what did they use to measure the stress response in people? Because they actually used things to measure this, to make the comparison.
There was like the BPM.
Okay,
I
so
think.
their heart rate, right? So that's one thing that was measured.
And then there's galvanic skin reaction, whatever that was.
The galvanic skin reaction, right? So they looked at the increased stress response by measuring heart rate and the galvanic skin, which is like how like sweaty your skin gets, if I'm not mistaken. They also noticed the kind of behaviors that people engaged in. So Xander, for example, would avert his eyes, right? He would turn away from people looking at him. And the conclusion, of course, was that the adolescents had much higher, much larger stress responses than the adult did. The adult did have a stress response, but nowhere near. They had to like change the scaling because the adolescent response was so high. So it showed that thinking about the self, you know, obviously in a stressful situation has a greater impact on an adolescent than it does on an adult. And it relates to the development of this part of the brain, the medial prefrontal cortex. Now, there's some other things that the medial prefrontal cortex is responsible for. So not just thinking about the self in social situations, what else is it involved in? Jordan?
Isn't it about like evaluating consequences of your actions?
Evaluating the consequences of your actions, absolutely. Anyone catch anything else?
Impulse control.
Impulse control. So teens are notoriously thought to have poor impulse control. And I know you're all really excellent people at the age of 13, 14, 15, which is when this sort of goes into hyperdrive. I know you all had good impulse control. But maybe your ability to think through decisions and actions are different. Would you make the same decisions at 13 that you would make now about things? Any thoughts on that? How many people think they'd make some decisions differently if faced with the same decisions that they faced at age 13? Would anyone decide something differently? You can raise your hand. Or they do exactly the same things in every situation? Because now you probably are better able to think through the consequences of your action. But another sign of this, I don't know how many of you have started driving, but you might know if you've started driving that your parents' car insurance goes up. For, you know, they might complain like, oh, insurance has gone up now that you're on our insurance or something like that. Or teens in general have to pay higher premiums for car insurance. And that's because teenagers get into more accidents than adults. Now, if you think about it, teenagers have better hearing, they have quicker reflexes, better vision. In every way, teenagers should be better drivers than adults. But because probably of poor impulse control or an inability to think through consequences of actions as much as adults, they tend to be riskier in driving and as a result get into more accidents. So car insurance is higher for teenagers than it is for adults, than for people who have longer periods of time on the road. And that entirely has to do with brain development. So kind of cool. So we've seen kind of like, and again, adolescence is genetic, it's biological, it's something that the body does, whether you want it or not. You can't really prevent it. It's kind of a predetermined schedule from birth, as he points out. So the next question, of course, and someone asked me this in the next class, well, once your brain is developed as an adolescent, are you done? Because actually your brain development or your development continues until the age of about 22. So your brain is probably still developing, and even some of your bones haven't finished developing, particularly your collarbones. For women, there's actually like a fusion of the collarbone a little earlier than it does for men. Men, the collarbone doesn't fuse completely, I think, until around age 22, which is kind of wild if you think about it. That's a little bioarchaeology there that I'm throwing at you. So we're going to continue with the movie. And the next question, of course, is, does your brain change in adulthood? Actually, let me ask the question. Do you guys think your brain can change in adulthood? I see a nod from Ramin. Anyone else?
Well,
Yeah.
I have a question. Like,
Yeah.
do physical changes due to, like, for example, your diet or things, for example, like if you eat too heavy, like oil, then your brain obviously will like get clots. Does that count?
Maybe. I don't know the answer to that, actually. I don't know the answer to that offhand, but I will show you, or David Eagleman will show you, some of the ways that your brain definitely will change. You can pretty much count that everything you do has an impact on your brain according to this, you know, if you take this perspective, and we pretty much do take this perspective. I mean, if you're like that the brain influences everything that you are. I mean, you could disagree with me. You're welcome to disagree with me. I'm not like a dogmatic, but I think most people would agree your brain really shapes who you are in some way or shape. Can oil impact your brain? Maybe, maybe not, but everything impacts your brain. So, but we're going to look at some things that definitely impact your brain. Anybody want to throw out some ideas? So we have diet as a suggestion. Anybody else want to suggest some things? Sydney?
Didn't they used to think that like the brain was like plastic after you started, like after puberty, and once you were like 25, your brain didn't change. And then they found that like by using certain pathways in your brain even more, you can like improve at things, even if it's not in the same way you would when you were a child.
Absolutely. And I think that's what we're going to start to see is a little bit about that plasticity of the brain. So absolutely. So the idea is that your brain, as you use things, the brain changes. And we're going to look at some very specific studies. Any other thoughts on what could change the brain?
In reference to Belinda's presentation, I feel like being in a sort of environment can actually influence the brain, like how it looks and what you think inside the brain. Like I feel like certain places or like certain cultures have approximately the same type of brain. I don't know if that's the term, but I think like it's kind of what I mean.
I think that goes back to that plasticity idea that if you're constantly reinforcing a certain neural pathway, that in turn, an environment might cause a certain neural pathway to be repeatedly used. That in turn would cause that to be stronger as opposed to one that is used less frequently. So if plasticity goes as far as that, as influencing how groups of people think, sure. Anyone else? Jordan?
Yeah, wouldn't like traumatic experiences affect an adult? Like when you have like adults with like PTSD and stuff?
Absolutely, that is going to influence the brain. Again, that goes into neural pathways being activated and also memory, which we're going to get to memory, maybe not today, but we might start to hear about memory today for some portion of today. All right, let's keep going with the video. I hope you're enjoying it so far. I mean, I always like watching it. Oh wait, there's many steps here. So we got to do a screen share. We have to do desktop one, optimized for things. Excellent. Okay. Share. Okay. And
the rush of our teenage years is.
All right, I'm back. I'm sure you all missed me for that moment. Everybody there? Yep, I'm seeing faces. Excellent. So going to that idea of plasticity and all the things that we do that affect our brain are going to influence who we are. So let's talk about the knowledge, because this is a really cool I think it's a really cool study, is that there were these cab drivers from London, and their job was to memorize spatial knowledge. So where things are located around the city of London and how to get from point A to point B in this very complicated route, I guess you could say. So how many years did cab drivers spend studying the knowledge? 4, right? 4 years, 3 to 4 hours a day. So that's a very intentional choice, right? To study this. You don't have to spend your time doing that. You could spend your time 3 or 4 hours a day playing The Witcher 3 on your PlayStation, or you could spend it studying biology, or you could spend it, I don't know, Snapchatting or watching TikTok videos. But whatever you spend your brain time doing is going to influence the area of your brain that's involved in that particular information. So the knowledge was spatial memory, spatial locations, and there's a certain area of the brain that is involved in processing that information. What area of the brain is involved in processing that information?
The posterior hippocampus.
The posterior hippocampus, exactly. Now, actually, if someone is presenting on the knowledge, you're going to find out that it's actually even more specific than that. There's like a left and a right side of the posterior hippocampus. But yeah, there's an area of your hippocampus that is involved in spatial memory. And so cabbies who studied for the knowledge, how did their posterior hippocampus change?
It grows in size.
It grew in size. So it got, in fact, someone explained this to me a few years ago, that it's actually like the neural connections got more dense. And what happens is, as those got more dense, other areas didn't get developed. So when you develop one area, it's kind of at the expense of another thing. Like there's a finite size that your brain could be inside your skull. So whatever you're developing is what's going to get stronger and reinforced, while other things will get weaker and to compensate for that, which I think is super fascinating. So the posterior hippocampus, and the longer you studied roots and locations, the stronger this area of your brain became. So just remember that whatever you're doing with your time, whatever you're doing repeatedly, that part of your brain is, you know, getting stronger every time you do the same thing, every time you think the same thoughts, every time you engage in the same behavior. So just remember that. Which again, it's super, super cool. And again, this is plasticity. This is the ability of your brain to change. Now, changing an area, of course, impacts different things that rely on that area of the brain. So he mentioned something else where people will very deliberately practice something over and over again and get better at it. What did he talk about that people get better at by practicing over and over again?
Like musical instruments, I think.
Learning a musical instrument. So people who learn an instrument, practice it, and, you know, musicians will sometimes spend 5, 6, 7 hours a day practicing their instrument. Maybe they spend an hour, maybe they spend 15 minutes, but that area of the brain involved in learning that instrument and processing it will give you some extra skills that rely on the same brain area. What are some other skills you can get if you practice a musical instrument?
I feel like your memory gets better, because when you'll have to memorize your pieces,
right? So he
everything
mentioned,
goes faster.
yep, better memory is one of the things that you have as you practice an instrument. Zhenling?
It was also mentioned in a video that musicians would like take shorter to learn languages. They had like linguistic talents in the sense.
Linguistic
Practice.
Exactly. So easier time learning languages. Those areas are all handled by the same part of the brain, or the same kind of brain pathways or circuitry, we might say. And so all those skills are strengthened. So just keep that in mind. Whatever you're doing, you're getting that part of your brain is strengthening at once. So everything alters the physical state of the brain, and our identities are not fixed. They're, as he says, a work in progress. So I hope that addresses some of the questions that came up about, you know, if you eat oil, will this affect your brain? Or if, and that may actually also affect just kind of how fast circuitry happens, nutrition-wise. But in terms of thinking and in terms of activating the brain, anything you do that activates the neural circuits is going to shape your brain and change it in some way. So we're going to move on to a slightly different thing, where what about unintentional changes of the brain? So things like disease or brain trauma, for example, and how that can impact the brain. So I realized I forgot. All right, we're back to recording as well. So again, so in addition to plasticity being something that changes the brain, the story of Charles Whitman shows us that something else can affect who we are and how we behave, involving the brain. So what happened to Charles Whitman? Go ahead, Jeannie.
He had a tumor pressing on his amygdala, which is the region that controls like fear and
Yep.
aggressivity, I think.
Yep, fear and aggression. So the amygdala is another part of your brain, another area in the brain that has something it's responsible for. And Charles Whitman, who to everyone else externally for most of his life, he had been, you know, an Eagle Scout, which is like, what is it called? Boy Guides or something like that. I forget what it's called. It's Scouts, I guess. He had been in the military. He was a student. He was a bank teller. He was going to become an engineer. And then all of a sudden, kind of out of nowhere, he kills his wife, he kills his mother, and then he goes on a shooting rampage from a clock tower at the University of Texas. And he had written, fortunately, a letter saying he had unusual thoughts, intrusive thoughts that he couldn't explain. And they autopsied his brain and found, you know, we can't be certain that it was the tumor pressing on his amygdala that caused him to behave this way. And not every brain tumor is going to affect the amygdala. But it's a reasonable, I think, a reasonable conclusion to draw that whatever was affecting this tumor affected him in some way that caused him to, that caused his brain to change. Or caused his like self and his identity to change from being kind of an upstanding citizen into being kind of a homicidal person, a psychopath, a sociopath of some kind. And although that's a very, like David Eagleman says, that's an extreme example. And obviously not every shooting that happens is because a person has a tumor on their amygdala. But he did mention that there are a number of diseases that affect one's self. What are some of the diseases that can have an effect on self?
Parkinson's disease?
Parkinson's disease, for example. Alzheimer's disease is another. So these are things that can affect who we are, and the medications to treat some of these diseases can affect the self. So one of the Parkinson's treatments causes a loss of impulse control. He mentioned compulsive gambling, but there are accounts of people who are treated for Parkinson's, and the medication they take causes them to lose inhibition. That's what it is, an inhibition loss. So they start running around naked, or they start having indiscriminate sex with people, even though for years they've been loyal to a single partner and monogamous. There are these effects from the medications that they're taking because the medication is affecting their brain and affecting structures in their brain. So that's something that happens. So diseases, drugs, anything we consume or do has the potential to affect us. I realize I'm out of time for the day, so we're going to continue watching this in the next class, and we'll continue stopping it and going through it as we do this. I may make a short video about how the brain works that corresponds with the reading that you have, because you have this reading like from a book called, well, it's just about how the brain works generally, because it goes a little more into detail, and it probably overlaps with stuff you do in this. How many of you guys are in a psych class or have taken a psychology class? It's like almost everyone. So you probably cover this. Do you guys cover in there how the brain works, like action potentials and all this stuff of neurons and things? You might eventually cover it in the class. Anyway, I'm going to make a short video just in case you don't have that available to you. It'll probably be the same. If I do, I'll ask you to watch it because I don't know if we'll get to talk about it very much. But the reading kind of explains the same stuff and a little bit about the history of neuroscience. So I think it's kind of just an interesting thing. Other than that, I hope you all have a lovely weekend, and I'll see you guys next class. If you have any questions, just stick around. I'll be happy to answer them. Bye.